Hello friends, welcome in Chemistry YouTube channel. I am Ramesh Vardar explaining about the inductive effect in the basic nature of amines. So this is a very important inductive effect. In my previous video, the basic nature of amines discussing with continuation of the same applications, that is the basic nature of amines. So the basic nature of amines is due to the lone pair which are present on the nitrogen. More appropriately, the aliphatic amines are more basic than ammonia due to the aliphatic group which are increasing the electron density on the nitrogen. Let's consider the more examples about the inductive effects applications. Example number 1, CH3, CH2, NH2, CH3, NH2, CH3, CH2, CH2, NH2. Okay. So let's consider example here. So this is the lone pair. This is lone pair. This is lone pair. Okay. The comparison between, we can call the example A, example B, example C. Okay. So in these examples, the electrons donates. This is plus I effect. This is plus I effects. In this plus I effects, the electron density is increases. So in this case, the lone pair, that is electron on the nitrogen, which are having the donating groups, that is CH3, CH2, and the electron density of nitrogen will be increases. Likewise, this is electron density. Small charge becomes big charge due to the donating the electrons. So this is the electron density is increased. In case of this one, as compared to this one, this is only one electron in the group. So electron density is like this. And example C, having the propyl groups which are used in the more increasing electron density. So this is increasing electron density on nitrogens. So which is having the highest density? The C having highest density. So that the basic strength of amines, according to the Lewis theory, C is more than A is more than B. So this is the order. So this is the example of basic nature of amines, in which this is a propylamine is more basic than ethylamine and then methylamine. So this is the example number 1. So let's consider another example. So these are the another example for basic nature of amines. This is first example. It is cyclohexyl. A example, B example, C example, D example. Cyclohexyl donate the electrons. So electron density will increases by positive inductive effect. In this case, this is a lone pairs, also donate the electrons. But this is cyclopropyl, this is cyclobutene, also increases electron density. But as compared to this one, is very small, also increase electron density. Comparatively, this is electron density for diagrammatic representation. Okay, in this case, as compared to this one, small. So in this case, only one group is here. So electron density not much increase as compared to this one. So this is the electron density. And in case of ammonia, there is no any group donating or accepting electrons, so that the electron density not increases or not decreases. So this is only the electron density like this. So this having a highest density, so that this is a very strong, then B, then C, then D. So this is basic nature of amines strength in case of example number 2. Let's another example number 3. So this is the example C. In this example, this is A, this is B, this is C, this is D. Okay. In case of first example, the electron withdrawing effect is here. This is minus I effect. So this is the lone pairs which withdraws, means electron density will decrease. In case of this one, this is also electron withdrawing. This also electron withdrawing. It also electron density is decreased. In this example C, it is electron density will increases. Electron density increases. And in case of example D, it is also electron withdrawing. So the electron density will decrease. So in example A decreases, in example B decreases, in example D also decreases. Means out of this, the C will be strong because electron density maximum in case of C. Then comparatively the Cl NO2 F, the minus I effect order for this group R, the NO2 is very strong, then fluorine, then chlorine. Okay, the strong effect minus I, NO2 is more than fluorine, then chlorine. Okay, so according to this one, which is having less effective, so chlorine having less effect, means more basic. See the example A, then D, then B. So this is the strength, this is the order. How? See once again, NO2 group is having highest power to attract the electrons, so that the acid base will be very least, so which is present in the last case. In case of fluorine, so order will be like the minus effect stronger in case of NO2, then fluorine, then chlorine. So basic strength exactly opposite to this one. So this is how the example number 3. Let's consider another example for basic strength of amines. The example number 4. So this is the example number 4. In this example number 4, every nitrogen having lone pairs, no doubt. Okay. So the upper part of 2 and 3 structures are same. So this is example A, B, C, D. So example A, B and D having same upper part. Okay. So this is aromatic. So aromatic amines are very weak base as compared to aliphatic amines. Okay. So it is in the C is with last. Okay. So very weak. Then which is electron density increasing, electron density decreasing, electron density decreasing. Okay. So out of this one, which is having electron density increases, so this is A. So A will be very strong. What is next? The B and D. So B and D. So Cl, then B, and then D. So this will be your answer. See once again. Out of A, B, C, D, which is electron donating? So this is electron donating. So this is the strongest base. So this is an example here. Next to that, this is the Cl, this is A NO2. So out of this one, it is where electron withdrawing is more, electron withdrawing is less. So that out of B and D, the strongest base is B, then D, and this is a very weak. So this is the order for basic strength of amines. So this is the basic strength of amines. In next example discussing the next lecture. Thank you.